Hello, and in this video we're going to look back over the three transformations of graphs, the main ones, that I've already done a separate video for those, but we'll put those all to one. Hello, and in this video we'll put together the three transformations of graphs I've done previous videos on separately, but we'll put those together as a revision and also throw in the modulus function and how to include that in transformations of graphs. So we'll start off by just looking at the first one, where you've got y as a function of x and you add a value at the end. And that's the sort of the simplest one. If you add a value at the end, it's just going to shift the whole thing up. So this graph, this point here would just move up, this point here would move up, everything would move up, and terrible drawing time, but it's going to look something like this. Obviously, if it's negative, it's going to go down. But if you put it on the inside the function, so function of x plus a, it's now going to move in the other axis. But you've got to remember that you'd think it would move to the right, but it doesn't. It moves to the left. So just get rid of this one. And this time, moving a, it's actually going to move it this much over. So everything now is shifted by a to the left. And the reason why it does that is because at this point you say, okay, well, for this value of x, go and find the value of minus 2 plus a, which is this much, and now bring that back to minus 2 and plot it. So it's like going to the right, which is why it's, because adding, you'd think go to the right, but saying, well, go to the right, but bring it back here and plot it. And that shifts it to the left. And if you take away, that shifts it to the right. So just remember that the x-axis usually does the opposite of what you're expecting. Okay, swiftly on, y is the function of x, but this time we multiply the whole function by an amount. Well, we should do a, really, to keep it general. And that's going to keep things the same on the x-axis, but make things twice as... I just wrote 2, a times taller, and underneath it's going to make it negatively taller. Is that a thing? I don't know. But it's going to stretch it out vertically. So it's still going to reach the same, it's still going to peak in the same place. That's a terrible drawing. But it's just going to be stretched out. So all the lines are steeper, both above and below the axis. And so we call that sort of a vertical stretch. And if we have it inside f of a times x, then again you'd think, oh, well, it's going to do it in the other axis, and it's going to stretch it again. But it's the same thing. It's saying that at this point, I'm going to go to an x value twice as far away, and I'm going to bring it back to where I was. So instead of making it a times bigger, it makes it a times smaller. So it's a stretch of 1 over a, or it sort of squashes it in, it divides by a. So this is going to bring this in by an amount a. The 3 is going to stay put, but everything's going to get squashed inside. If we have the last one that we've previously done, we can have minus the function of x. And if we do that, we're going to get a flip. It's just going to flip it. And it's going to flip it. Let me have a little think. It's going to work out the function, then it's going to flip it vertically, because you're going to work out the function as it would normally be, and that's the y value, and then you flip it because you put the minus, so it goes upside down. So that's going to give us the opposite of what we have in flipping around the x-axis. So that's a vertical flip. Well, that's the same symbol, so that's no good. So we'll put a reflect on that, reflecting that way. And it's the opposite if we put it inside. Obviously it can't go the wrong way this time because it's just reflecting it, so there's no direction. It's going to be a reflection in left and right in the y-axis. So again, we'll put reflect. And that's going to look like the 3 staying still and everything else doing something like that. Terrible drawing, but hopefully you can see what I'm trying to do. Just flip it left and right. Okay, and then as promised, the last thing that might come up is the modulus. So what if we do y equals the modulus of the whole thing? Well, that means that we work out the whole picture, finish the mod, there we go, the whole picture, and then we make anything negative positive. So at the y-axis, it comes shooting up here. Okay, that's probably a curve actually, isn't it? Because that's curving down, but you get the point. That's going to come up like that. If you do it if you do it before the function, so f of, mod x mod bracket, f of, let's say that carefully, f of the mod of x, then what's going to happen is you're going to make all your x values positive first, and then plot the function of x as normal. So this is fine, because this is what we'd normally get. But here, at -1, you're going to say, oh, but actually work out the value of +1, make it positive, and what's the value, but plot it over here. So you're going to get a mirror image of whatever you had on this side is going to get mirrored on this side. And all this curve and all that just goes away. It's just going to mirror that right-hand side on the left. Okay, so with that in mind, let's try and do these for examples. Minus f of x plus 4. We always do BIDMAS when we do these. So f of x exists. Minus f of x is going to reflect it. I'm going to do it dotted because I've got the 4 to deal with. And then we've got to plus the 4, so it's going to shift the whole thing up by 4. So if that's 3 there, then that point there is going to come up higher. So it's going to come down like this. That is 4 tall. So that point here, this point here is now -4. So that's going to come and touch the axis. And then this point here is 3, or -3, sorry, because that's that point there reflected. So that's going to come through at 1, badly drawn, but you get the point. And then that's going to do something like that. Okay. Now, obviously, in these questions, you do need to know what the points are. So we label that as 1. This is going to be -1, 0. And that's it. It doesn't cross the axis in another place, so we don't need to label those. Okay. Let's try again for next question. Just get rid of these. Hang on. Let's draw a loop round. -2 of times f of x plus 1. So we do the bracket first, BIDMAS. X plus 1 is going to shift it left, so it's going to move over here. So it's going to look like this. Okay, so I'm not sure about that one just at the moment, because it's whatever this value is over here. We'll come back to that. This point is going to be -2, 4, because it's moved across, and this point is going to be -3, because it's all moved 1 across. And then it's -2 lots of it. It's the minus on the outside, so it's going to flip upside down, and the 2 is going to make it twice as tall. So this stays here, but it's going to come down now. So that stays where it is. But this is going to get a lot bigger, which I can't really draw, but it's going to be -2, because it's still on the x value is the same, but that 4 is going to become -8. It's going to be twice as big and negative. So that's that coordinate there at the bottom. And then it's going to come back, and it's going to do that. And we just need to worry about what this value is going to be. That's a tricky one, because what we want is the value of f of x up here somewhere. So I'm not entirely sure. We'll come back to that. Maybe you can write in the comments what I'm missing there. But I know that point there has moved over and then got twice as big, but we need the point that was the value at 1, because then that moved over, then that became negative and twice as big. Yeah, I have to think about that. I've not drawn this very clearly either, because I need to. Yeah, it's because I haven't got enough space. This is supposed to be twice as far away, and my reflection here, this looks like the same distance as this, but that should be twice as tall. It should really come up like that, because you've got to make sure that your picture looks right. And if I left it like that, then it doesn't look like I've made it twice as tall. So just be careful on that one. Okay, oh, wrong one. Grab that, circle it, and delete. Right, here we've got a mod this time, so 2 times f of mod x. Okay, so we said mod x is when we say, okay, well, this is the positive stuff, and then for the negative x values, we're just going to plot what the positive is. So it's just going to look like that, and we delete all of this, but then 2 lots of it, so same again, it's just everything's going to get twice as big. So it's going to come up here to 6, and then down, oh, that was terrible, and then down again like that. So that was nice and easy. And the last one, 2x minus 6, but all done before we do anything. So again, we're going to look at BIDMAS, so we're going to do the 2 times the x first. So 2 times the x, but inside the bracket is going to squish it all in. So that's going to get tighter in like this. Oh, I should have done that dotted to say that's my working out. So that's minus 1. This is minus 0.5, but still at 4. That's still at 3, because the y values haven't changed. And then minus 6, it's going to move everything to the right by 6. So if that's minus 1, it's going to move the shape, same shape, but instead of minus 1, that's going to be 5. Obviously, not done it to scale. And if that's minus 0.54, then that's going to be 5.54, like that. So it's just a case of knowing this. You have to know what the various transformations do, and then picking them out in BIDMAS order. So you do the things in the bracket first, as you'd expect. You do the timesing, then the adding, and then you do the things outside the function, and you just do each one in turn until you've moved your graph all the way out. If you have any questions, you can put them in the comments, but otherwise, ta-ra for now.